to get familiar with if we're going to start plugging things into our motherboard. So from the motherboard, it needs to connect things to things like the CD drive, if you want to read a DVD or a music CD or a software CD. It needs to be able to plug into your hard drives, which we're going to go into further detail here about. Your hard drive is where everything's going to be stored. So whenever you install a program or you flash a bit of software, it's going to stay on your hard drives so that the next time you turn on your PC, it's still there and you don't have to go through the process again. To connect such things, they are now using SATA connectors. These rectangles here with a little L shape in the center, that's how it communicates between the device it's telling to do something and the motherboard itself. Let me see, I've got a couple SATA connectors here. If y'all want to pass them down, if you want to check that out, if you want to check that out here. And all it is just a cable that will relay data between the motherboard and the component that it's speaking to. Okay. So again, the display here, it's kind of in this bottom right corner, and it'll be in different places on multiple motherboards. If you go to buy one, they'll have them generally in the same spot, but if it's not exactly where you're looking for it, it's not a big issue. In comparison to the one we have here, it's a little more on the right, but they serve the same purpose. You would plug in those same cables into the motherboard and then ultimately to the hard drive or to the optical drive that you're running inside of the case. Now, while up here, let me also give you a peek at the CPU. The CPU is sitting here, and if I flip it upside down, it doesn't come out because it's locked into what's known as its socket. That socket's very important because if you buy different kinds of motherboards, you'll find that only certain CPUs fit in certain sockets. And it can get really confusing. It can take a little bit of Wikipedia to figure out which ones are compatible with what. But again, some of these websites are going to account for that. And when you're on the market for a motherboard and you place it in the same cart as your CPU, it'll give you a warning as to whether they're compatible or not, as well as some recommendations of which ones are. So that's good to know. Let's see what else we have on that diagram of the paper for the motherboard. I believe we're also looking at our RAM DIMM slots. So these long portions to the right of the CPU is for our RAM. RAM stands for our random access memory. And I'll show it to you here. Where are they hiding? They're thin sticks like such. And they've got small rectangular modules on it, which are the flash memory by whatever company makes them. Samsung creates RAM, as well as I believe some other flash areas. I forget the companies, but the ones that distribute. Yes, exactly. And the Corsair is a brand that repurposes as well and makes it available to the market. So the more RAM you have in your system, which you would install here, not really the faster it will run, but the more capable it'll be doing of multitasking at any given moment. So that's one reason we want to install more RAM in our system. Now, as far as the sizes of memory you'll see when you go onto the market for one, I believe you'll see things in increments of like 4 gigabytes per stick. They also have them available in 8 gigabyte flavors, so that if you put them together and you set maybe like 4 of them in a single system, you can have around 32 gigabytes of RAM in your system. That's if you're really going to take it to the edge, you can place a high amount like that. I'd say a recommendation for a modern day PC, 8 gigabytes will get you about what you need, and if you want to push it to the limit, 16 will also serve you well. What else do we have on here? Here's a further example of what we're looking at. As far as the SATA ports go, if you notice, these are different motherboards. They got different color schemes, and the SATA ports aren't exactly where you'll find them on every single one, but they serve the same purpose. And if you ever get lost, luckily a lot of these manufacturers will put the labels of what we're looking at right next to the port that it associates with. Now on this next slide, it's not going to be super important when you're looking for new computer components, because this is what we refer to as legacy, meaning that it's kind of a dead technology and we're not going to see it much. It's kind of a history lesson. So this rectangle, we're going to get into that. That's our hard drive. If you've seen a hard drive, that's where everything's stored. What we're focusing here on is the connection. So on the bottom part, these wires are smaller and more sleek, so they're the newer standard. They go by SATA. S-A-T-A is the standard for these connectors. They have higher bandwidths, meaning they can transfer more data over their wires, as well as have a slimmer profile so that your computer doesn't get too cluttered with cabling inside. In the past, maybe closer to, might have died off around 2005 or 2006, from like the 80s to that point, we used what's referred to as an IDE cable ribbon, IDE. And what that had is all of the information that it would send over was distributed across this flat ribbon cable type deal that had individual wires spread out through it. But when you place it inside of a computer, it was flat and wide, and it would kind of block the airflow for your components, which we're going to talk about why airflow is important, because things are going to get hot inside of there. So that was back in the IDE days, as well as the power management wasn't as reformed. That was back in the Molex. If you ever see Molex on a PC description, it's talking about some old hardware, so you might want to look at a newer item or click forward. So the hard drives that I had mentioned about are generally this size. This is a 3.5-inch hard drive, and it is a mechanical device. And what that means is that even though it uses electricity to turn it on as well as store a lot of the information, it has a mechanical physical arm on the inside that moves around across a metal disc to write the data to it, which has worked just fine up to a point, but because it has physical parts, it's destined, it's kind of doomed to fail at some point in the future. And we don't want that. Let's take a look at the inside. Here's that metal disc I was talking about with a spindle in the middle that will rotate that disc at high speeds, either depending on 50, 200 rotations per minute, and some of the higher end ones are 7,200 RPM, 7,200 rotations per minute. And here's that arm I was talking about. It's a little actuator that with a needle on the end, so every time it needs to write bits of data, it goes physically to the areas on the disk and writes it. But if you were to bump it or physically shock it or drop it accidentally, it would mess up your memory and you could corrupt everything that you've done, which is bad if you got research on it, or if you got, family photos or all your resumes on it. You don't want to lose that stuff. So the solution to that is a different kind of memory. What they have nowadays, and it's getting cheaper and cheaper, is solid state memory. So whereas if you were on the market for a hard drive, it would be abbreviated with HDD, hard drive disk. Instead, the newer solution is an SSD, solid state drive. And this is completely electronic and free of mechanical parts, meaning that if we had taken it apart and shown its insides, there's not a little metal arm on the inside that's moving around. If it were to get bumped or shocked or dropped, all of your information would still be saved because it's all instead saved on flash memory. Flash memory being the key. So those are really neat. They hit the market to the open consumers maybe around also 2006 and 2007, 2008. But the technology was fairly new, so if you wanted to get one for your own PC, it was mostly just by guys that were already in the PC game, knew how to build, and wanted to front the money for a new technology. But back then it was pretty expensive. Nowadays on Amazon Prime, you can find a good bit of memory for about $80, $100. But what I haven't mentioned, also from being safe, they're worlds faster than a mechanical drive like this. SSD is much faster than a hard drive. So if you were to place some software on there, it would load up much quicker. What you got there?
So, how much gigabytes will $80 get you for a solid-state drive?
In the past, $80 would get you hardly anything. When it started to become a sale, it would barely get you 60 gigabytes, which can fit maybe, you know, your operating system of Windows 10 or Windows 7, but then you wouldn't have a lot of space for actual programs or pictures or videos. Now, since the prices have gone down a bit, $80 would get you closer to 120 gigabytes to maybe 250 gigabytes. So I know if you wanted like a terabyte, which is, what is that, 1,000 gigabytes? If you wanted mass storage like that, they're still being sold in hard drives at about $80. Just because creating a hard drive is cheaper. It's cheaper, it's a more refined technology, it's been around longer, they know what they're doing. So larger storage is still done in the older version of the hard drives. And 1 terabyte SSDs were almost unheard of for a while. And then places like MIT and Japanese manufacturers over at Samsung have been pushing the boundary ever since. But if you wanted a terabyte in an SSD, it could cost you more than $500, $600.